Let's start our discussion of 7 R's of migration by first talking about relocate. In this chapter, I would focus on relocating VMware workload from on-prem to VMware Cloud on AWS. I would skip Kubernetes and Docker discussion here because that would require going in depth of Kubernetes and Docker. Probably I will point you to some links where you can find more information about it if you are interested. Let's talk about relocate. Let's first understand it and then we'll go into the technical aspect of it. So when I talk about migrating through relocation, it says migrate application and data from data center, cloud provider, could be any other cloud provider, or a different region to an equivalent cloud infrastructure of another cloud provider or region. Maybe you were running your workload on XYZ cloud provider. Now you want to bring it to AWS. Maybe you were running it on premises. Maybe you were running it into one region of AWS and you want to relocate them to another region. This is also referred as hypervisor level lift and shift. So what we are doing here that we are keeping the same base layer. It could be hypervisor, it could be your containerization layer, and on top of it we are performing lift and shift. Now, if there are 7 strategies, each strategy would have their plus and minuses. I'm just trying to make things here clearer through the good, bad, and ugly analogy here. Probably you have seen this Western movie, and we will try to understand what is the good part about relocation, the bad part, and the ugly part about it. Let's discuss that. So first one is that it minimizes downtime and disruptions and user remain seamlessly connected during the migration process. So as an end user, I would be accessing a service and I would keep on accessing it. There would be nothing changing from my side. At the back end, relocation would just keep on moving your workload from one source to one backend to another backend, but your front end would remain the same. Consider like you go to office, you shifted your house, but your going to office is still going to remain same. Obviously, it may be a little different route you have to take now to reach to office, but probably nobody would know unless you tell them that I have shifted the house because you would see they would see you into the same time in the office every day. So it doesn't make difference to them. Same thing, it minimizes downtime and disruption since user remains seamlessly connected during migration. There is no impact on ongoing operation. The way I was doing things, I will keep on doing it. No need to rewrite application, source code. No retraining of staff or investment in upgraded hardware is required. Maybe you are using some automation script. Maybe you are using some backup software. They would keep on functioning because it is still just the location change, but the whole architecture is untouched. It is still exactly the same. So that could be a good thing. What could be the bad thing associated with it? Let's talk about that bad thing. It is not able to take advantage of cloud native feature. What you did, you just migrated it as it is. You are not using any feature which cloud may provide. I need scalability. I may want to use managed services. That may not be there in this type of workload because you just changed it from one location to another. You are still maintaining the operation, so you may not be seeing the benefit you should achieve from managed services. What are you doing in on-prem? You are still doing the same thing like patching, then managing, then security, and then configuration. That is also you are doing here also. So that doesn't change. So that not be a good thing for you. That is a bad thing. The ugly part is you need to continue maintenance and compatibility with existing application on the new platform, and that can use time and resources. That's what we need to maintain compatibility. All my backend application or my existing application, if they're talking, I need to ensure that communication channels are open, they are not being blocked, that they are being updated. So that's why it may be time and resource consumption. And there may be not too much benefit in terms of cost saving because you are still paying the hypervisor license cost and there is operational overhead too. You were using VMware environment, you are still using VMware environment. It is a good way to migrate, but maybe the cost involved is still there. You may get little bit scalability, but there is still cost is not as compared to other options which we will be discussing. Which tools you may use? You may use AWS services like VMware Cloud on AWS and Amazon EKS if it is a container-based workload. So where this will fit in, we will talk about relocation. So this is server migration or workload migration. So we will be focusing now on VMware Cloud on AWS. Let's talk about what is VMware Cloud on AWS. Before we understand how VMware Cloud on AWS works, we need to understand basics of how VMware's software-defined data center actually works. They call it SDDC, Software Defined Data Center. The concept is simple, that on top of whatever hardware you are using in your physical data center, VMware would add a software layer, and all your component which you use to configure on a physical layer, now they would be configured through the software layer, and whole data center resources are virtualized, and that's why we call it software defined data center. So we have customer data center that is made up of physical servers. There would be, I'm showing it one, there would be hundreds and thousands of servers depending on a customer's data center. And these servers need to communicate to each other. They need storage. So probably physically there would be network devices coming from different vendor and storage devices which may be coming from different vendor. So this layer is the hardware layer of your data center. Once you want to virtualize it, the first thing you probably will start with would be VMware vSphere, or it is commonly called as ESXi hypervisor. This is the software component which serves as a base operating system of your physical server. And once this operating system runs on top of it, let me call it hypervisor. Once it hypervisor runs on top of it, it is able to convert or present, convert is not the right word, present the physical resources as virtual hardware. So your CPU becomes virtual CPU, RAM becomes virtual RAM, same you have virtual hard disk, you have virtual network card. And if I have to run a operating system needs all these things, CPU, memory, disk, network. So we would provide that into a form of a virtual machine. Virtual machine would be leveraging the virtual hardware which are presented by VMware vSphere server. And on one server, you should be able to add multiple virtual machine depending on capacity and other performance requirement. And you may not have one VMware vSphere server, you may have hundreds of them, maybe thousands of them, and to manage them, you would need a management component which is called vCenter server. So vCenter is the manager, whereas the actual work of running virtual machine is done by VMware vSphere server, which are running on virtual, which are presenting virtual hardware through physical hardware. So that would take care of your compute, CPU and memory. What about storage? I still need to learn about how EMC storage array works or how NetApp storage array works. What if I want that as a software defined solution? So in that case, there is an option in VMware or a software component available which is called vSAN, virtual SAN. It would present you storage into a virtual format. It's a virtual SAN, so you should be able to still perform things like RAID or availability or performance characteristics on that, but it is all done virtually. So now they have put storage virtualization on to play. Third component which is remaining for a full virtual data center is network, and for that they have a product called NSX that will help you to virtualize your network. So once you have your management platform vCenter, hypervisor vSphere, vSAN storage, NSX network, what you have actually done, you have converted all the hardware component into a software format, and that is called your software defined data center. So I hope this thing is clear that what is software defined data center. So customer run the software defined data center in their own on-prem world. Obviously that would mean there are some connectivity, there are some scalability challenges, there are some performance challenges if you are running too much workload, and that's where cloud's flexibility and scalability comes into picture. So let's now talk about what is VMware Cloud on AWS. So VMware Cloud on AWS is a jointly engineered solution by combining forces of VMware and AWS. VMware provides the software layer, AWS provides the physical infrastructure layer to run the software. So if you are running VMware on your on-prem environment, this is what your infrastructure may look like. You may have vSphere, vSAN, NSX, vCenter server managing it. That is called VMware Cloud Foundation. What you have here is a private cloud. You are limited in terms of how much capacity you can provision in private cloud. Okay. We want to expand, we want to go to different regions, so AWS global infrastructure can be of use here. VMware servers or vSphere server or vSAN NSX, they require a hardware to run. What if AWS global infrastructure is providing that hardware from their data centers, region, availability zone. So once this global infrastructure supported infrastructure is available, on top of it, VMware software can be installed and this would become VMware Cloud on AWS. So AWS is providing the hardware, VMware is maintaining the software on top of it. It's a managed service, so they would take care of update, patch, and other thing. You just say I need a cluster with 10 hosts, 20 hosts, or 10 cluster, 20 cluster, and those resources would be provisioned for you on demand without you worrying about installing, patching those things. So that is a service which is being offered. So obviously now what you have, we have a link between two. What you can do on your, there is something called hybrid vCenter linked mode, and through this linked mode, you are able to see both the servers into one single interface. And I will show you this into a screenshot, and you would be able to then perform migration if the need be. And it's not stopping here. What you could leverage now, you could start leveraging native AWS services too. So maybe simple example could be, okay, I would be running my workload here into VMware. I would host my application or servers here, but I would host load balancer into native AWS services, ELB, Elastic Load Balancer. And this load balancer will forward traffic to VMware Cloud on AWS virtual machine. So that integration is also there. Now your VMware Cloud on AWS can leverage AWS native services like S3, Lambda function, data lake, RDS databases, whatever. So what you have now is a public cloud. And if you are willing to like leverage both for your use cases, like you are doing data center expansion, or you are creating a disaster recovery solution, or you are trying out new things, what you have now achieved, you have achieved a hybrid cloud architecture, which is made up of a private cloud on-prem as well as a public cloud provided through AWS. That's what we are getting here as a hybrid cloud. The good part here of this method is whatever tools and feature you were using, whatever runbooks your employees have created, whatever backup software was running, whatever monitoring software was running, it would still keep on functioning in the same way because at the core, it is still the VMware software which is running here. Now, how you get started with these services? So I've included a link for getting started guide. You could get this VMware Cloud on AWS service either through AWS partners or directly through AWS, or you could engage VMware sales team to get hold of this. So this document link, I would be providing the link, but this is a nice way to understand how you actually get started with. So you could purchase through VMware, you could purchase through AWS, and then you can purchase through a managed service provider. That is also possible, and once they are, then you can go ahead and then leverage different services on AWS also. They provide all detailed information about purchasing checklist, and also do check this document if you want to know a little bit more. Now this service may not be available into free tier. If somebody of you want to get hands-on, there is not physical hands-on, but there is a click-through demo available through VMware Hands-on Lab. So I'm including a link also for that. Let me quickly show you how VMware Hands-on Lab actually looks like. So I'm here on VMware Hands-on Lab menu, and I should be able to search from catalogs of lab and then start doing some labs. So I'm here in catalog, and let me search about AWS. Probably all the lab which are available, I should be able to see this. It will show 120, 90, 30. These are duration. These are free labs, most of them. So I could go ahead and say, okay, I'm looking for a lightning lab or a fundamentals lab, which may start for 90 minutes. So let me go through that. Let me start the lab. It is not going to give you a physical environment, but it will provide you a click-through demo way to start working with your services. So let me log in, and we would be probably able to see this thing into action. So I'm logging in. Anyone can register here, should not be an issue. It is available for anyone to register. Let's see what we can get here. Sorry, let me reset my password. Give me a minute. I'm logged in. It was just a typo. So what I see here now that these are the activity which I can perform through this HOL. HOL stand for hands-on lab. So it will tell you what the lab guidance details are, and then it will go through the various steps of what is cloud computing, how VMware cloud work, what are the use cases, and then it would go into detail of about how the implementation would be actually working if I want to get started with. So this is a lab overview. I could go and see this information, some fundamental details, and now I could say I want to set up HDDC, software defined data center. So let's go to hands-on interactive simulation. So this is interactive simulation. It would help you in seeing where you have to go. So you do not actually do anything like physically, but here you are able to select this link. So that goes to AWS account. I would be performing some login. All these instructions are provided into this guide if you see here at the top. And once I'm there, I should be able to then search for some services and then get started from there. So I'm looking first to set up a VPC. Once the VPC is set up, because this VPC would be used for communicating from your AWS services up to your your VMware environment. So you could find this labs very useful just to get a hands-on or understanding on how the solution actually would be working. So do check out these labs. There are various available, like there are walkthrough for VMware Cloud Tanzu services, there is FSX related lab, networking, migration related labs. So lots of free labs are available for you to try out. So hopefully this thing is clear that how it is going to work. Now it comes that how we are going to actually migrate our workload. Let's talk about migration process now. So let's say we subscribed, we have set up our networking, we have established a communication between vCenters, we have our native AWS service communicating. What are the methods for me to start migration? Let's talk about that. So here you see the setup of two places. One is on the AWS side. So here what you are seeing on the right is your AWS infrastructure, global infrastructure of AWS on which software defined data center is running. And we have vSphere, which is providing the server virtualization, NSX for network virtualization, and vSAN for storage virtualization. And once this is ready, you could then run virtual machines on top of it. If you see, you could directly go and deploy virtual machine in a native VMware format if you need. On the other hand, on the right side, what I am seeing a on-prem data center. On this on-prem data center, we have vCenter server software to manage it. We have storage. This could be coming from third-party vendors. That's not mandatory to use the same vSAN also, and then only you can migrate. So you may have here some different type of storage, different type of networking setup. Still, you can leverage NSX-based services into hybrid into AWS cloud on it, VMware cloud on AWS. You could use it. Now, how this works actually, behind the scene, there is a technology which is called hybrid linked mode. What this hybrid linked mode will do, it would connect these two vCenter servers so they are now aware about the inventory of each other. And now, once you have permission, you could say, okay, I have some virtual machine who needs to be migrated here. Some machines need to be migrated on this layer, whatever. So I could now start migration once I have a channel formed between these two vCenter server. Obviously, I would still need network connectivity for actual migration to happen, but the control plane operation would happen through this hybrid linked mode. So you decided you did that hybrid link mode. There is a detailed documentation available which you can use to connect these two services. Now comes migration part. So you may start with thinking about, okay, I can do something called cold migration. As the name says, it is cold. Cold in the sense that it is not actually running or actually delivering any services while it is happening. It is cold. It has to be started. So it is backup and restore mechanism. What you could do, you could use tools of your choice who understand your vCenter server and other infrastructure, and you can perform backups here. Once these backups are ready, you could copy these backup into software defined data center here and then perform restore here if the need be. This is same software. Let's say I was using XYZ software for backup. It understands vCenter. It would understand this vCenter also, and it would be easy for me to backup and restore. But obviously in this case, there would be some downtime required. So whatever, it could be minutes, it could be hours, it could be days, depending on how you transfer your data to vCenter and how much data it is. So that is the cold migration approach. Second approach is that, okay, we cannot afford maybe that much of downtime. What we can do instead, so we could do something like warm migration. Warm migration says that there is very low downtime here. How we do it? We perform replication. So that is a continuous replication based mechanism. This is your virtual machine which is running, let's say, on on-prem, and then you have your virtual machine which is running on AWS. You set up a virtual machine which is a replica of this virtual machine, and you start performing replication between them. So there would be downtime when you do cut over, but it is a low downtime. What is actually happening here? You are performing replication of your data, maybe on a scheduled basis, to your AWS based VM, and that's how you can perform warp migration. Low downtime, but it is using replication. Third option is, which we refer as live migration. Live migration's concept is there is no downtime. It uses some proprietary technologies of VMware called VMware vMotion or VMware HSX vMotion. I'll explain that. But idea is virtually more machines would be moved while my users are connected. So let's say I am a user and I am accessing services of this virtual machine. My admin started migration. So this machine would be moved to any other service provider's VMware infrastructure, but I won't be witnessing that. From a user's perspective, nothing would be visible, no downtime. That is what we call vMotion, and that is also referred as live migration. Now, in some places you will find more information. Live migration further divided would be something in called on demand. I need to migrate right now. Let me right click the virtual machine and migrate. And second one is called scheduled. You have put together a specific schedule when you want to perform that migration. It will be still live, but it will be performed at that very moment which you selected. Probably it is a period of less business activity. So I was talking about vCenter linked mode. What vCenter linked mode is, this is how the screenshot would look like once you have things set up. So here we have VMware vmc.com. Here is another vCenter server. In that, these are virtual machine, like this is Cloud DS3 client. I could right click this machine and select migrate and then send it to here. Or you could just simply drag and drop some services if the need be. So I want this Linux machine to go from cpbu.lab to this VMware CDC. I could just drag and drop, and behind the scene, the required network communication would be started, memory would be transferred, disk would be transferred, any device connectivity which is there would be managed, and that's how you would be able to perform migration through vCenter hybrid linked mode. What this hybrid link mode uses for all these type of migration, it uses a specific tool which is called VMware HCX, that stands for VMware Hybrid Cloud Migration Extension. And this particular piece of software, once configured, it can be used for cold migration, it can be used for replication, and it can be used through vMotion, so there would be no downtime associated. So this is a free of cost software available for you to get started for your migration, and I have included a link where there is a hands-on lab associated with that too. So please check that hands-on lab also, where you should be able to use vCenter VMware HSX getting started with cross cloud mobility. So you would start with migration, you perform migration, hyper V to vSphere, mobility optimized networking, lots of information you could enroll and get started with this lab also. That is VMware hands-on lab. So I hope by this time you have a better understanding of what is relocation. It is a hypervisor level lift and shift, and through this we are able to run our application using the same native format what was in my on-prem onto a cloud infrastructure. So I hope this thing is clear, and we will be discussing the remaining migration strategies as we move forward. I'll stop here and I'll see you into the next section. Thank you.